Hello sir, my name is Yefta Elnatan from Geometric Technology, Night Regular. Now I'd like to share about satellite remote sensing. Satellite remote sensing is a method of obtaining information about an object, area, or phenomena from a distance without making direct physical contact. This information is obtained by analyzing data captured by sensors on satellites, aircraft, or drone. In satellite remote sensing, there are several basic concepts. First is electromagnetic spectrum. Electromagnetic spectrum is range of all types of electromagnetic radiation, from radio waves to gamma rays. Each type of radiation has a different wavelength and frequency. In remote sensing, satellite sensors are designed to detect specific ranges of the electromagnetic spectrum, such as visible light, near-infrared, and thermal infrared. The second basic concept is radiation. Electromagnetic radiation emitted or reflected by objects on the Earth's surface contains information about their physical properties, such as temperature, humidity, and chemical composition. The third basic concept is absorption. The atmosphere absorbs some electromagnetic radiation, especially at certain wavelengths such as ultraviolet and thermal infrared. The next basic concept is scattering. In the atmosphere scatters electromagnetic radiation in all directions, which can reduce image contrast. The last basic concept is emission. The atmosphere also emits electromagnetic radiation, especially at thermal infrared wavelengths. In satellite remote sensing, there are several sensor characteristics. In here, I give three sensor characteristics. First is spatial resolution, the ability of a sensor to distinguish two adjacent objects on the Earth's surface. The higher the spatial resolution, the more detailed objects can be identified. Example: if the spatial resolution of an image is 10 meters, the smallest object that can be distinguished is 10 times 10 meters. The second sensor characteristic is spectral resolution, the ability of a sensor to distinguish objects based on difference in their spectral reflectance properties. For example, a multispectral sensor can capture light at several different wavelengths, allowing it to distinguish between types of vegetation, mineral, or pollutant. Next sensor characteristic is temporal resolution, the frequency with which data is captured by the sensor. For example, Landsat satellites have a temporal resolution of about 16 days, meaning that images of the same area can be acquired once every 16 days. The last sensor characteristic is radiometric resolution. The ability of the sensor to distinguish the brightness level of objects. For example, high radiometric resolution allows us to distinguish objects with very small difference in brightness. Okay, now there are image processing in satellite remote sensing. There are three image processing. First is geometric correction. Geometric correction is a process to correct geometric distortion in an image due to sensor, atmospheric, or terrain relief. Next image processing is radiometric correction. Radiometric correction is process of correcting brightness variation in an image due to atmospheric sensor or lighting condition. The last image processing is contrast enhancement. Contrast enhancement is process of increasing the contrast between the object and the background in an image so that the object becomes easier to be identified. Okay, satellite remote sensing is a technique that utilizes data collected by satellites to study the Earth from a distance. This data is then processed into useful information for various fields such as meteorology, agriculture, geology, and urban planning. As technology continues to develop, the application of satellite remote sensing will become wider and more diverse. Okay, sir, there are several some sharing for me about video on your talks. Thank you.